You've built an AI-powered dice roller, but now you need to control who can use it without blocking the AI itself. We'll implement JWT Authentication in just a few lines, showing how to generate secure tokens, configure the server to require them, and pass them through Anthropic's API, all while keeping the dice rolling smoothly. From FastMCP, import FastMCP. From FastMCP server auth import JWTVerifier. From FastMCP server auth providers, JWT import RSA key pair. Import random. Key pair equals RSA key pair. Generate. Access token equals key pair. Create token. Audience equals dice server. Auth equals JWTVerifier. Public key equals key pair. Public key. Audience equals dice server. MCP equals FastMCP. Name equals dice roller. Auth equals auth. At MCP, tool. Def roll dice, end dice. Int list int. Roll end dice, 6-sided dice and return the results. Return random, randint 1-6 for in range end dice. If name equals main. Print f \n \n dice roller access token. \n access token \n n. MCP. Run transport equals HTTP. Port equals 8000. This demonstrates the authenticated RPC tool pattern, where Python functions become remotely callable endpoints with built-in security. The code shows how to expose a simple dice rolling function as an AI-accessible tool while adding JWT-based authentication, separating business logic from transport and security concerns. What makes this distinctive is the combination of declarative tool registration with pluggable authentication providers. The pattern works through a layered architecture where decorators handle tool registration, while authentication becomes a composable middleware component. The FastMCP framework manages the RPC contract, parameter validation, return types, automatically from Python type hints, while the JWTVerifier operates as a transparent gatekeeper. This separation means your tool logic remains pure Python, unaware of how it's called or secured. This approach solves two key problems: securely exposing backend logic to untrusted clients and eliminating RPC boilerplate. It's particularly valuable for AI integrations, where you need to expose tools to models like Claude while preventing unauthorized access. The trade-off is framework dependency, but the clean separation between tools, auth, and transport often justifies this for microservices or AI tooling scenarios. Let's break it down. From FastMCP, import FastMCP. From FastMCP server auth import JWTVerifier. Imports FastMCP, the core class for creating AI-callable tools, and JWTVerifier for validating JWT tokens. These are the foundational components for building secure, AI-accessible functions. Key pair equals RSA key pair. Generate. Access token equals key pair. Create token. Audience equals dice server. This generates an RSA key pair for JWT authentication and creates a signed access token. The audience claim restricts this token to the dice server service, preventing unauthorized use across other services. This is the standard JWT setup pattern for service-to-service authentication. Auth equals JWTVerifier. Public key equals key pair. Public key. This instantiates a JWTVerifier using the RSA public key, enabling secure authentication for incoming requests. The verifier validates that each request's JWT token was signed by the matching private key and intended for this specific audience, preventing unauthorized access to the dice roller tool. MCP equals FastMCP. Name equals dice roller. Auth equals auth. instantiates the FastMCP server with authentication enabled. The name parameter identifies this service as dice roller in the MCP network, while the auth parameter enforces JWT validation on all incoming requests, ensuring only authorized clients can call the tools.
At MCP, tool. Def roll dice, n dice, int list int. Roll n dice, 6-sided dice and return the results. Return random, randint 1/6 for in range n dice.
The @MCP tool decorator exposes this function as an AI callable tool. FastMCP converts the type hints and docstring into a structured schema that AI models use to understand and invoke the function. This follows the tool function pattern: pure logic with typed inputs/outputs, no side effects beyond the return value. The list comprehension efficiently generates the dice rolls in a single expression.
If name equals main. Print f \n and dice roller access token. \n access token n n. MCP. Run transport equals HTTP. Port equals 8000.
This is the standard Python entry point guard. It prevents the server from launching when this module is imported, ensuring it only runs when executed directly. The print statement outputs the JWT access token for client authentication, while MCP run starts the FastMCP HTTP server on port 8000, exposing the dice roller tool to connected clients. FastMCP JWT Authentication pattern. This example demonstrates FastMCP's built-in JWT verification system, where RSA key pairs generate tokens that servers validate before exposing tools to clients. The audience claim in your JWT must exactly match the audience parameter in JWTVerifier or authentication, will silently fail with 401 errors. Always treat development utilities like RSA key pair as temporary scaffolding. Production systems require proper key management infrastructure.
The token that proves your identity carries no identity of its own.